Hello, and welcome to Game Gems. Today, we're going to look at one way to implement a fairly important quality of life feature, volume sliders. Volume sliders, which tend to be mapped to music, sound effects, and sometimes speech, give the user the ability to balance their audio in a way that's ideal for their preferences. They're not particularly difficult to implement, but they do involve a couple of different components that are useful to understand. Let's start with a quick overview of Godot's audio system. Audio in Godot is handled by way of the audio stream player nodes, which route the audio through channels known as buses, which is a word that's never going to sound natural to me no matter how many times I say it. An audio bus is a way to separate sounds into groups. You can adjust the volume of all sounds played through the bus, as well as add effects to it like chorus and reverb. Godot automatically provides you with a master bus, and unless you add your own, all audio goes through that master bus by default. We don't want that though, so let's create some new ones. Click on the Audio tab at the bottom of the Godot editor to open the audio bus display. As you can see, your master bus is the leftmost one in the list. Click on Add Bus to add a new audio bus, then click its name and rename it to SFX. Repeat this process, but name the second bus BGM. I didn't implement any background music in this sample project, but the process is the same as it would be for the sound effects I'm going to add in a moment. With our buses set up, though, let's add the ability to manipulate them via script. Create a new script in your project and call it Options. Make it an autoload script so that we can access it from anywhere in the project. The Options object is primarily responsible for setting the volume levels, notifying the UI that they've been changed, and loading/saving the settings to disk. Let's implement those things now. First, define two signals. These signals will fire when the volume levels have been changed outside of the UI, like when we load them from disk. Next, define an enum called Audio Bus Channels and provide it with the names of the three channels in your Audio tab. We're going to use them to provide a convenient way to manipulate the buses in a moment. We'll also define a constant with the name of our options file. When we save the options to disk, it'll use this file name. Finally, define two variables, one for each of your volume levels. Default them both to 1.0 and implement a setter method for each. The setter simply assigns the new value to the variable if it's different from the old one, and if it does, adjusts the bus volume via a method that we'll implement next. Speaking of which, here it is. The method takes two parameters, our audio bus enum and the appropriate volume level. Volume levels are defined by a range of decibel values. 0 dB is considered normal volume, while anything below that, up to -72 dB, is quieter. At -72, the volume is completely silent. In the other direction, anything above 0 dB is boosted and not only will be louder, but runs the risk of clipping the audio and distorting it. We'll keep the max volume of our sliders to 0. The actual volume, then, will range from -72 to 0. The value of the slider changes from 0 to 1, which we can treat as a percentage. Multiplying the minimum decibel level by this percentage and subtracting it from said minimum will give us the appropriate value between -72 and 0. Note that this is not the exact way to calculate volume levels in audio. It's a little more complex than what I've described here, and you can find the exact formula with a little Googling. This variant works well enough for our purposes, though. After we have the decibel value of our slider setting, we need to set the correct bus to that volume. This is handled by the Audio Server object, a global singleton that Godot uses to interface with its audio system. The setBusVolume method takes the index of the bus we want to manipulate as an integer, which is why we defined our enum at the top of this file. Enums are simply a dictionary of ascending integer values, which, if you define the elements of the enum in the exact order as the buses are listed in the Audio tab, the enum values will map to each bus exactly. This will keep you from having to remember which bus is at which position. Just don't move them around after you define them without updating the enum or it'll break. Anyway, we need to implement the loading and saving of our settings. Settings are configuration options, so let's use Godot's ConfigFile class to make this a breeze. Config files are simple text files that group variable values by category. If you open one in a text editor, it'll look something like this. As you can see, the two volume setting variables are crammed together directly following the category label. The file itself is saved in your Godot user data directory, the location of which varies by operating system, but is usually somewhere in your user data directory. Consult the Godot documentation to find the file path for your data directory if you need it. Normally, you won't need to ever look at the file directly, but being able to view the file's contents is occasionally useful for debugging, so it's a good idea to know where they're stored. Anyway, let's revisit our options autoload and look at the load and save data functions. They're both identical and very straightforward. First, we'll save the data. All you need to do is create a new variable of type ConfigFile, then call the class constructor. After that, simply indicate the category, variable name, and value of the variable before calling the save method, passing it the file name you want to save to. We've defined it as a constant earlier in the file, so all we need to do is append that file name to the user:/path so that Godot will put it in the right place. ConfigFile objects are automatically closed when they go out of scope, so we don't even need to manually call the close method before exiting the function. Loading the file is just as easy. Again, create a ConfigFile object with .new, then call its load method with the same file path you used earlier. The load method returns a status code, so make sure that the return value is equal to OK before attempting to use the file's contents. Provide the category and variable names to the ConfigFile's getValue method and assign them to your volume variables. Their defined setters will automatically be called here, which then sets the actual volume levels in the mixer. We also need to emit the relevant signals to let the UI node update itself, which will then technically update the variables again, but nothing will happen because they're being set to their current values. This is one of the reasons we don't emit the signals for the variables being updated directly from the setter, by the way. Helps us avoid an infinite loop. Okay, now that the bulk of the code is done, we can design our UI. The sample project linked in the description below shows you one way to do it, but feel free to come up with your own. The only thing you really need to care about is the settings of the HSlider component itself. As the slider is supposed to represent a percentage value from 1 to 100, we want the slider's range to go from 0 to 1, and increment in intervals of 1/10 of the slider's maximum value. To this end, we set the appropriate min, max, and step values, and also give it 11 ticks and enable the ticks on borders option. This will let us snap our slider handle to all of the 1/10 intervals from 0 to 1, including both maximum and minimum values. Since I have a general UI handler node as well as an options screen node, I have a script attached to each. In the options screen node, connect the slider's value changed signals to a pair of methods that will handle them. These signals are fired when the slider value is changed by the user, so we want to update the volume settings when they do. Here's mine. Note how we simply take the slider value and set the corresponding options variable to it. Your options screen will also need methods to handle the options autoload signals, so define those as well. When the options screen node is notified of the variable values changing outside of the UI, they'll automatically set the slider's positions to the new values. In this tutorial, this only happens when we load the settings from disk. Finally, go to your main UI node and, in its ready function, connect the autoload signals to the options screen's relevant handlers, then load data from the disk. If there's no data file, no load will take place, and the sliders will simply default to whatever initial value they were set to in the editor, which is usually the maximum value. This is fine for our purposes. Make sure you connect the signals before you load the data, or else the sliders will not update properly. You also want to save the volume data at some point. I do it whenever the user leaves the options screen. Optionally, here's a quick bit of polish you can add to your options screen. Add an audio stream player node somewhere in your UI, grab a reference to it, give it a sound file, and call its play method whenever you update the FX volume. This will give the user a preview of the new sound setting without them having to leave the options screen. Don't forget to set the bus value of that audio stream player to the SFX channel so that it's routed through the right place. And that's all for today. Thank you all for helping this channel grow, and if you find these tutorials useful, don't forget to like and subscribe for more game gems. See you next time!